Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Christina binti Zulkifli.
Hi, my name is Pavitra Malini anak perempuan Najamukti. My matrix number is B1325103005 and I'm from Bmkt section 1/2.
My name is Safia Masara binti Muhammad Zulkifli. My matrix number is B132510797 Bmkt section 1/1.
Hi, my name is Shaza Atira binti Darun and my matric number is B1325102274.
My name is Elisa Dilali binti Hamdan. My matric number is B132510311.
Today, we are going to talk about the application of OM. Our device is oscillator. So, what is an oscillator? An oscillator is a device that can produce a repeating signal. It can generate different types of waveform, such as sine waveform and square waveform. It also can convert DC power into an AC signal. Now, what is an OM oscillator? An OM oscillator is an electronic circuit that uses operational amplifier and feedback to produce stable periodic signal. There is three common types of OM oscillator. The first one is Wien bridge oscillator. It can generate sine wave signal. RC phase oscillator also can generate sine wave signal, but it uses resistor and capacitor. The last one is square wave oscillator. It can generate square shape signal by switching between high and low voltage levels.
Now, let's proceed with the types of op-amp oscillators. For the first example, we have Wien bridge oscillator. The Wien bridge oscillator produces a sine wave output. It has a high stability and low distortion, and it is commonly used in audio signal generators. The second example, the type that we have, is RC phase shift oscillator. So the RC phase shift oscillator produces a sine wave output as well, and it uses resistors and capacitors to create a phase shift. The RC phase shift oscillator is suitable for low frequency applications. The third type is the square wave oscillator. Now the square wave oscillator, like its name, produces a square wave output. It is a simple circuit design and is mostly used in timers and clock circuits. Now, let's talk about why an oscillator is important. So the oscillator is important as it generates timing signals, it produces reference frequencies, it helps create audio tones and signals, and it supports communication system.
I'm gonna present about who regularly use oscillators. The first one is electronic industries, such as engineers use oscillators in electronic devices such as computers, calculators, and microcontrollers to generate clock signal that synchronize circuit operation. The second one is telecommunications. Oscillators generate carrier frequencies for transmitting and receiving signal in mobile phones, radios, televisions, and more. The third one is audio engineering. Oscillator create audio frequencies used in sound generators, musical synthesizers, alarms, and testing audio equipment. The fourth one is medical equipment manufacturing, and the last one is automation and control system. The next slides, I'm gonna talk about when are the oscillators used. Number one is whenever a repeating signal is required. For example, An oscillator is used whenever a continuous repetitive electrical signal waveform is needed without requiring a continuous external input signal. The second one is during clock generation in digital circuit. For example, digital devices need a clock pulse to coordinate operations. Oscillator generate these clock pulses, ensuring all components work at the correct timing. The third one is during audio signal production. Oscillator produce sounds frequencies that can be amplified and converted into audible sound in speakers, musical instrument, and alarm system. The fourth one is during wireless communication, and the last one is during signal test and measurement.
I will cover where oscillators are found and how an op-ampere oscillator works. First, let's look at where oscillators are commonly used in our daily life. Actually, oscillators are widely used in many electronic devices such as digital clocks, radios, mobile phones, signal generators, computers, and alarm systems. These devices depend on oscillators to function properly. For example, in digital clocks, oscillators generate a constant frequency to keep accurate time. Without it, the clock may become inaccurate. For radios and mobile phones, oscillators are used to generate signals for transmitting and receiving communication. In computers, oscillators act like a heartbeat that controls of the timing operations. It ensures all processes run in sync. So, overall, oscillators are very important because they provide stable, continuous signals that are needed in many systems. Next, we move on to the how an op-ampere oscillator works. The main concept is that it can generate a waveform continuously without any external input signals. First, DC power is supplied to the circuit. This provides the energy needed for operation. Then, a feedback network takes part of the output signal and feeds it back into the input of the op-ampere. This feedback is very important for the oscillators to function. The feedback used here is positive feedback. This means the signal is reinforced instead of reduced. This helps the circuit to maintain continuous oscillation. As a result, the circuit continuously generates a waveform such as sine wave or square wave. This waveform can be used in many applications like signal generation or timing circuits. For example, in alarm system or communication devices, this continuous signal is very important to ensure stable operation. So, in conclusion, oscillators are widely used in many electronic devices around us. The op-ampere oscillators works by using positive feedback and power supply to continuously generate signals. This makes it very useful in communication, timing, and electronic systems.
Okay, for advantage, oscillator circuit have a simple design and are low in cost. They provide a stable frequency and are easy to build. For disadvantage, however, the frequency can change due to the temperature variation. The output power is limited and component tolerance can affect accuracy. So for overall, oscillator are widely used, but for environment factor can influence their performance too. In conclusion, Bmkt oscillator is a useful application for an OMPs. It generates continuous signal and it is widely used in many electronic device. It is reliable, simple and cost-effective. Without oscillator, modern device like phone and camera, computer would not work properly. That's all for our presentation. Thank you.